అందరికీ నమస్తే. ఈరోజు మనం ఈ వీడియోలో ఫైండ్ ద ఎల్సిఎం అండ్ హెచ్సిఎఫ్ ఆఫ్ ద ఫాలోయింగ్ ఇంటీజర్స్ అప్లైయింగ్ prime factorization method. So according to real number chapter, it is a third question. Before we are going to discuss about this question, మన ఛానల్ ఫస్ట్ టైం ఎవరైనా చూస్తున్నట్లయితే ప్లీజ్ సబ్స్క్రైబ్ చేసుకోండి అండ్ క్లిక్ బెల్ ఐకాన్ ఫర్ మోర్ అప్డేట్స్. సో LCM and HCF of the following integers applying prime factorization method. The first question is 12, 15 and 21. Let's take question number 1, 12. In the first previous video, we have completed 1, 2 questions. Now, third question is 12, 15 and 21. As we are taking prime factorization method for 12 and for 15 and for 21. Like the factorization method is like this. Taking the prime numbers, first 2, 6, again 2, 3, it is also a prime number, so here we stopped. Thereafter taking 15, it is divisible by 3, 5 are 15, 5 is a prime number, and here also divisible by 3, 3 7s are 21. Now taking prime factorization of 12 is equal to 2 into 2 into 3. Prime factorization of 15 is equal to 3 into 5. Prime factorization of 21 is equal to 3 into 7. Now in that common factor of these both is only 3. Therefore HCF is equal to HCF of 12, 15 and 21 is equal to common factor as the HCF. Therefore LCM is equal to common factor into extra factor. So that means common factor is 3 and extra factor is 2 into 2 into 5 into 7. Then the multiplication, first keep you aside 2 5s are 10, 2 5s are 10, 3 2s are 6, 6 7s are 42. Your 10 aside is there, 42 into 10, 420. LCM of 12, 15 and 21 is 420. Similarly, 17, 23 and 29. But here we are directly taking because all three are prime numbers. For suppose here we go, we get 17 ones are, then 23 ones are, and 29 ones are. So prime factors of 17 is equal to 17 into 1. Prime factors of 23 is equal to 23 into 1. Prime factorization of 29 is equal to 29 into 1. So there is no any common factor, but 1 is the common factor of the numbers. So common factor is equal to 1. HCF is equal to 1. HCF of 17, 23 and 29 is 1. Here we go, question number 2. So there, and LCM is equal to LCM HCF into extra factor or common factor into extra factor. Now common factor is 1 into extra factor is 17, 23, 29. Now the multiplication of these, we get the final result is 1, 1, 3, 3, 9. So to multiply in calculation 17, 23 is ones and remaining 29 is ones. So you're getting 11,339. Okay, clear? When it is clear, I'm going to third question. So next, find the HCF and LCM of 8, 9 and 25. So the given question is 8, 9 and 25. So question number 3, taking 8 and 9 and 25. So first of all, it is an even number. 2 4s are and 2 2s are is a prime number. 3 3s are is a prime number. 5 5s are. Now prime factors of 8 is equal to 2 into 2 into 2. Prime factors of 9 is equal to 3 into 3. Prime factors of 25 is equal to 5 into 5. So now the common factor of 8, 9 and 25. There is no common factor in out of this. So there is no any common factor. Writing 1 about this you have is equal to 1. LCM is equal to 1. Therefore LCM is equal to direct all 2 into 2 into 2 into 3 into 3 into 5 into 5. So similarly, previously I solved like that 5 2s are 10 keep aside. Again 5 2s are 10. 5 2s are 10, 5 2s are 10 keep aside. And remaining you have 3 3s are 9, 9 2s are 18. 9 2s are 18 and 10 into 10 100 118 is 1800. 1800 is our LCM. Again you multiply to get first 5 2s are and again 5 2s are. This is 10 and this is 10. Hereafter 3 3s are 9, 9 2s are 18, 10 10s are 100, 1800s are 1800. This is the easy method to calculate this answer. Question number 4. Given that HCF of 306 and 657 is equal to 9, find the LCM of 306 and 657. Already we know that LCM into HCF is equal to product of two numbers. So we know the formula. We want to know LCM is equal to product of two numbers by product of two numbers by HCF. Now applying these values in this formula, we know LCM of 306 and 657 is equal to product of two numbers is these two numbers only. 306 into 657 by HCF is 9. Now the calculation, the 9 is divisible and 306 is divisible by 9 for suppose, and separately you can divide it 306 with the 9. 9 3s are 27. Then getting remainder 3 and 6. 9 4s are 36. Remainder is 0. Then we go 9 1s are 9, 34s are. You have 34 into 657. Now the multiplication of 657 into 34. 4 7s are 28. 4 5s are 20, 22. 4 6 are 24, 26. And similarly, 3 7s are 21, 3 5s are 15, 17, and 3 6 are 18, then 19. 1 second, 4 7s are 28, 2 in the mind, and 4 5s are 20, 22, 4 6 are 24, 26. Right, we go. And addition 8, 3, 7 or 3, 30, 10, 12, and 2. It is equal to 22,338 is the LCM of 306 and 657. Once again, LCM is equal to product of two numbers by HCF. Now applying the values, here we go. So product of two numbers is given two numbers is 306 and 657 into that, and the calculation by the division you getting about 34 to cancelize the 306, and remaining we have 34 into 657. Then multiplication to get 22,338. So then the next question is check whether 6n can end with 0 for any natural number. If the number want to end with 0, it must be divisible by 0 or 5. I mean divisible by 5. So according to divisibility rule 5 says that 0 or 5 at one's place. If the number ends with 0 or 5, it must be divisible by 5. That is the divisibility rule 5. So suppose if 6n wants to end with 0, it must be divisible by 5. So if the number 6n ends with 0, it's divisible by 5. So because the divisibility rule 5 says that the number ends with 0 or 5, it must be divisible by 5 at units place. Similarly, factorize prime factorization of 6 power n, that is equal to 2 into 3 whole power n. In this prime factorization, from the above prime factorization, here no factor 5, no prime factor as a 5. So it is clear that 6 to the power of n cannot end with 0 for any natural number. For any natural number n. So for example, I am taking here, you go 6 to the power of n is given. Suppose n is nothing but, here n is equal to 1, 2, 3, 4 and so on, because it is a natural number. So then we go, first applying 1, 6 to the power of 1 means only 6 into 1 is equal to 6. 6 to the power of 2, 6 to the power of 2 means 6 2 times, 6 into 6, 36. 6 to the power of 3, 6 into 6 into 6, 6 6 are 36, 36 6 are 6 6 are 36, 6 3s are 18, 18 3, 2 1 6. So you observe these three. When you take any of the natural number at power, but the number gives the result only 6 at ones place. Here not end with 0, not end with 0. So that is why 6 to the power of n can not end with 0 for any natural number. That's why I am writing here cannot end with 0 for any natural number. So once it is clear that, the next question is explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. So why these numbers are composite number means, before, what is the definition of composite number? A composite number means more than two factors. Any composite number, it has a more than two factors. The two factors, one under except other numbers. That means say except itself. One itself is a prime factor. Other than these two factors means more than two factors is called a composite number. See, composite numbers means composite number means more than two factors. More than two factors are called composite numbers. Why these numbers are composite numbers? Let's make it from 7 into 11 into 13 plus 13, 13 plus 13. So in this, I am taken as a common 13. Why we take as a common factor? Then we go 7 into 11 into, when 13 is taken as a common here, and it is 1 plus and then 1. Now we go 13, 7 11s are 77, 77 ones are 77, plus 1 is there. That means 13 into 78. Now as the factors of 78 you have, and 2 is there, 2 3s are 6, 2 9s are 18, and 3 1s are 3 3s are. That means 13 into 2 into 3 into 13 are the more than two factors. More than two factors. Hence 7 into 11 into 13 plus 13 is called composite number. Composite number. Similarly, I am taking it from 7 into 11 plus 13 plus 7 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Here in this I am taking as a common 5. Are you taking 5 as a common? Remaining one as it is 7 into 6 into and 4 into 3 into 2 into 1 plus 5 is a common 1. And here also 5 is 1 is there. 1s are also same number. Now the multiplication you have 5 is as it is. Then 2 3s are 6, 6 6 are 36, 7 4s are 28. 7 4s are 28. Otherwise 7 6 are 42. 4 3s are 12, 12 2s are 24. 42 into 24. 7 6 are 42. 4 3s are 12, 12 2s are 24. 4 2s are 8, 4 4s are 16, 2 2s are 4, 2 4s are 8, 8 10, and also 10. That means 1008 plus 1 is there. Here we go. Then 5 into 1009. So it is also has a, it has more than two factors. Hence the number is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. So we have last question in this exercise. Next question is there is a circular path. Circular path. Suppose it is a circular path. Here, sports path. Sonia and Ravi move around the circular path one round. Sonia takes 18 minutes, while Ravi takes same round 12 minutes. But when Sonia and Ravi starts at a same point and same direction, they move. But when did they meet again? Sonia and Ravi start same point and same direction. They move same direction. When did they meet again? So when did they meet again means let us will take the LCM of 12 and 18. Suppose it is a 12 and it is a 18 that the common method 2 by the factorization method 2 6 are 2 9s are 3 2s are 3 3s are. Last question in this exercise. And so all of common. Therefore LCM is equal to 2 into 3 into 2 into 3. That means 2 3s are 6, 6 2s are 12, 12 3s are 36. So Sonia and Ravi meet after 36 minutes in the path. After 36 minutes they meet in the path. This is the this exercise 1.1. Thank you. Have a nice day.